This video is on exercise 1C, questions 2 to 4 of A-Level Further Maths Core 1 textbook. Now, in question 2, the first part is about simplifying 4 plus 5i times 4 minus 5i, and we have to give the answer in the form a plus bi. So we need to expand this, and we start by multiplying 4 by 4. So 4 times 4, 4 times 4, then 4 times minus 5i, 5i times 4, 5i times minus 5i. 4 times 4 is 16, 4 times minus 5i is minus 20i. 5i times 4 is plus 20i. 5i times minus 5i is minus 25i squared. And we know that I squared is -1. So let's write it down first. Minus 25i squared. But I squared is -1. So -1 times minus 25 gives us plus 25. And we can now simplify this. So minus 20i plus 20i is 0. 16 plus 25 is equal to 41. And this is the final answer. B. 7 minus 2i times 7 plus 2i. So it's exactly the same as the previous question with different numbers. 7 times 7 is 49. 7 times 2i is 14i. Minus 2i times 7 is minus 14i. Minus 2i times 2i is minus 4i squared. Again, the same as the above example, I squared is -1. -1 times -4 is 4. So 14i minus 14i is 0. Then we have 49 plus 4, and this is equal to 53. So part C is asking us to comment on your answers to parts A and B. So it's as simple as just saying that both of the answers are real numbers. So that's basically what we should mention here. Real numbers. That's what we have got. D. Prove that a plus bi times a minus bi, which is exactly the same as the form of the questions that we have been doing, is a real number for any real numbers a and b. So it's it's simpler than it looks, because we have a plus bi times a minus bi, and we need to prove that, which is a very straightforward proof. This one, we simply need to expand this. So a times a is a squared. A times minus bi is minus a bi. Bi times a is a bi. Bi times minus bi is minus b squared I squared. So again, the same thing happens here, because I squared is -1, and -1 times minus b squared is positive b squared. And minus abi plus abi is 0. So we get a squared plus b squared. And we know that both of a and b are real numbers. Therefore, the sum of two real numbers is a real number, and we can say that a squared plus b squared is a real number. So this just means that it's an element of, and this is just a symbol of, real numbers. So that simply means a squared plus b squared is a real number. Or you can simply just write in words. 3. So given that a plus 3i times 1 plus bi is 25 minus 39i, find two possible pairs of values for a and b. It's a very common question, and we can solve this by the technique called equating the coefficients. So the very first thing we do is again expanding these two brackets. So let's do that first. A times 1 is A times BI is ABI, 3i times 1 is 3i, and 3i times BI is 3bi squared, and I squared is -1, so we get minus 3b. So that's what we get by expanding the bracket, which is equal to 25 minus 39i. So let's check the left hand side and see if we can, write that in a nicer form. So let's, write the real numbers next to each other like this. So so one of our real numbers is a, the other one is minus 3b. So a minus 3b. So this is our real part of the complex number that we have on the left hand side. And then its imaginary part is ab plus 3 times I is equal to 25 minus 39i. So remember that the second thing that you do after expanding is that you simply try to write that in the form a plus bi, where a is just represents where you write all of your real parts or real numbers, and bi is the other part for imaginary. And now we use the technique called equating the coefficients, because we know that a real number here plus an imaginary number is equal to 25, which is the real part. So let's write here, and here's imaginary, and is equal to minus 39i, which is the imaginary part here. So we equate the coefficients, which means that we set the real part of the left hand side equal to the real part of the right hand side, and same thing for the imaginary part. So ab plus 3 is equal to minus 39. And now we have two equations that, this can allow us to solve and, for the values of a and b. So now we can so let's rearrange this equation and add 3b to both sides, so we can make a the subject of this equation. If we do so, we get 3b plus 25. So a is equal to 3b plus 25. Now let's substitute this into the second equation. So here we write 3b plus 25 times b plus 3 is equal to minus 39. Now let's expand and simplify this. So 3b squared plus 25b, and let's add 39 to both sides, so we get 42 is equal to 0, and we have a quadratic equation. So now we can solve this to get the values of b, and once we have found them, we can then use them in order to get the values of a, because we are probably going to get two values for b, which means we will also get two values for a. And even in the question it says two possible pairs, so they've already given us a hint about that. Now let's solve this equation. I'm going to use the quadratic formula for this equation. So minus 25 plus or minus the square root of 25 squared minus 4 times 3 times 42 divided by 6. So under the square root is equal, so we get 121, and the square root of 121 is 11. So we have minus 25 plus or minus 11 divided by 6. And now we minus 25. So we are going to get two values for b. So one of them and the other one. So the first one, let's do with the positive one. So minus 25 plus 11 is minus 14 divided by 6. This can be simplified to minus 7 over 3. And the second value of b, let's do with the negative this time, and we have minus 36 divided by 6, which is minus 6. So these are the two possible values of b, and let's find the corresponding a values for each of these. And if b is minus 7 over 3, then a is equal to, so we've already set this, which is 3b plus 25. So 3 times minus 7 over 3 plus 25, and we get 18. And for the second value of b, so a will be equal to 3 times minus 6 plus 25, and we get 18. So, sorry, not 18, it's 7. So these are the two possible pairs of values for a and b. So when b is minus, oops, I wanted to highlight that. So when b is minus 7 over 3, a is 18. And when b is minus 6, a is 7. So these are the possible values for a and b. 4. Write each of the following in its simplest form. So before I start doing this question, we should notice that I to the power of 1 is I, which is very obvious. I squared is minus 1. Then I cubed is simply I squared times I, which is, we know that I squared is minus 1. So minus 1 times I is minus I. I to the power of 4 is I squared times I squared, which means minus 1 times minus 1 is 1. And it's very interesting because after I squared, this starts to, it's like a loop. It gets back to this bit because I to the power of 5 is I to the power of 4 times I. I to the power of 4 is just 1. 1 times I is I. Or I to the power of 6 is I to the power of 5 times I. And we know that I to the power of 5 is I. I times I is I squared, which is minus 1. So you can see very square. And this question is all about that. So the first one is I to the power of 6, and we've already answered that. That's equal to minus 1. The next one, 3i to the power of 4. So 3 to the power of 4 is 81, and I to the power of 4 is just 1. So 1 times 81 is 81. Now the second one is I to the power of 5 plus I. I to the power of 5, as we have written here, is I. And plus I is 2i. And finally, the last one, 4i cubed. So that's equal to 64i cubed minus 4i cubed. We know that I cubed is equal to minus I. So for the first one, we get minus 64i. And for the next one, we get plus 4i. Because negative I, so that negative with this negative makes this positive, so that we get 4i. And minus 64i plus 4i is minus 60i. That's it for this video. So I hope this helps, and make sure to subscribe for more videos. Thank you for watching.